That sounds glorious. Good plan. It does sound like a great plan. All right, so we are starting chapter 8. So I have the notes up here for 8A, but chapter 8 is actually about the unit circle. Are you guys so excited? No? No, but I did have. Okay, so about the unit circle, did you guys get handed one when you were in trig last year?
Oh yeah.
That thing. I know Miss Ewan suggested that we got out compasses and did it, which I thought would be really fun, but we're not going to. Eventually, I will be handing you one. Okay? We don't really need it today, but I will be handing you a unit circle. Did you guys realize how important these were when you were in trig last year? Did it come to you? I would like to let you know that I think it's awesome that you guys realize that. My high school teacher never taught me that. And then I got to college and I was lost. And my professors were like, what? So be glad that you're going to learn more about this today. Not today, but this chapter. So we're going to first start talking about radian measures. Did you guys look at those last year or not so much? A little bit? Okay, so we're going to start with radian measure. Tomorrow we are going to get into arc length and sector area, which you were taught in geometry. We're also going to learn how we can use radians with those, so that will be the new part of that. On Friday, then we'll get into unit circle and trigonometric ratios. We'll get into applications of the unit circle. We'll talk about 30, 60, 90, and 45, 45, 90 special right triangles. Let's get to that. And then we'll talk about how we can actually write some equations with our trig functions and stuff. That'll be at the very end. So a lot of sort of different stuff in this. And you might notice we are sort of hitting the trig section. So from chapters 8 through 11 are all pretty much related to trig in some way. So starting today. It'll be good. We'll be good. Stat box, everybody got that? So we're going to talk about degrees because that is something you guys should be familiar with. I know you guys worked with degrees when you were in geometry, whenever that was. So keep in mind that a full rotation around a circle is 360 degrees. So 1 degree can be defined as 1/360th of a circle. Everyone feel pretty good about degrees? How do you know a number is a degree when you look at it? Yeah, it has to have that little symbol. Do not leave that symbol off. If it's a degree, I have to see that little circle symbol. Okay, so do not leave this. This is really important that you have that to let me know that it's a degree. Because if you leave it off, I'm going to assume that it's a radian. Now, yeah. So make sure you've got that symbol for a degree. And again, we're kind of used to degrees. You could eyeball 90 degrees, right? And from that, maybe eyeball a 30 or 60 or 45. You can go from there. So we're probably more comfortable with those degrees. But then we'll also talk about how we can use radians as well and be able to use both as we go through the next few chapters here. Okay, so the reason why you have to have that little circle if it's a degree is because you don't have to have a symbol for radians. Now, we do sometimes use that little C, sort of like a small c in the superscript to be a radian, but we don't have to. If you leave that c off, that's actually okay. But if you don't put the 0, or not the 0, but the O for a degree, that's not okay. 1 radian is about 57.3 degrees. Now, on the back of this unit circle that we're going to give you is actually a chart, which is mainly for your knowledge, not necessarily something you'll really use a lot, but it compares degrees to radians. So when you guys get this, you can kind of check that out, and it sort of goes through the degrees and the radians. You can compare those sizes. Now the whole deal with a radian is just if your radius and your arc length are the same, then you would get like 1 radian. So it's a little bit weird. It's a different way of measuring those. Well, I still like to call them degrees. Like that's what you're more used to. Okay. Questions so far? We all know what a radius is, right? We'll talk more about arc length tomorrow, but you guys remember what that is? Okay. So again, you get a radian when the radius and the arc length are the exact same measure. So here is our conversions. So it's a degree radian conversion, and so we can actually use it both ways. You can see we've got this nice circular diagram that came right out of your textbook. One thing to know is that pi radians is equal to 180 degrees. So that's a big relationship here. So what we've got, and this symbol, so it's not quite equal. This symbol is sort of like the approximate. So we'll treat it as if it's equal, and I think you guys, if you've used radians before, probably that'll sound familiar from what you did last year. So if you have pi radians, that is about equal to 180 degrees. So if you have the value in degrees, let's say it's 35 degrees or whatever, and you want to change it into radians, you have to multiply it by pi divided by 180. So today's going to be about practicing some of those conversions. So if you start with degrees and you want radians, you multiply by pi divided by 180. If you have the radians and you want to convert that into degrees, it's the reciprocal. It's 180 over pi. You might want a calculator going forward here as we are going to start working on some conversions. We're going to start with converting degrees to radians. And we will have some where we convert the radians to degrees as well. All right, so we're going to start with converting these degrees to radians. It says in terms of pi, so when it says in terms of pi, does anyone know what that means? Absolutely. Leave pi in your answer. So you don't want to times it out and have a big long decimal. You're going to leave pi as in your answer. Now, I know this stuff is not in your packet, so do take a little bit of time to try to remember which is which. You don't have to be a master of it before you walk out of the door today, but just kind of keep that in mind to remember those. So, I've got my degrees to the radians. I have to multiply by pi over 180, so I've got 60 times pi over 180. And so I'm just going to sort of multiply this out to start with because I want to leave pi in there. So if I'm multiplying fractions, I can put 60 over 1. And I can multiply the numerator and the denominator. So I've got 60 pi over 180. And then what we can do is simplify 60 over 180 and then leave pi alone because it says in terms of pi. I don't want to put that all in my calculator. So how does 60 over 180 reduce? 1/3. So you could have pi over 3. That's the way we usually write it. Or it would not be incorrect to write 1/3 pi if you wanted to. But we do usually write that as pi over 3. How about you guys try 18? degrees and convert that into radians. Okay, I feel like I'm mostly seeing that out there, so if I put that together, I've got 18 pi over 180. And so when I reduce that, it ends up being 1/10 or pi over 10. You will have some problems where it doesn't say in terms of pi, so when in doubt, how far should you go if you've got a bunch of decimals? 3 significant figures. I mean, looking at your assignment, in one of the problems it does state 3 significant figures to remind you, but just kind of keep that in mind. Like if you're not sure, do 3 significant figures, otherwise the problem will tell you how far to go. Alright, so now we're going to convert to degrees. So we're going like the other way. So convert this to degrees. We have to multiply it by, if you take a look in your notes, 180 over pi. So I've got 3 pi over 5. So that's in radians. And notice it doesn't have that little c, which is okay. We can drop that c part of it. So we'll multiply this by 180 over pi. We're not going to cross multiply, but I think you're thinking the right thing. I just said the wrong way. Yeah, like simplify the cross. I always say cross reduce. I know it's not really a thing. That's just something I say. Okay. But yeah, you can simplify or reduce those. So the pi's will cancel out. Just nice. So I end up with, I'll have to do 3 times 180 in my numerator and then 5 in my denominator. Sure, you can do some more reducing if you want to. I ended up just multiplying my numerator. So 540 divided by 5. Yep. So when I divide that out, I get 108 degrees. Make sure you got that degree symbol so that we know what you're talking about. We're just going to have one more example, but I think you might have noticed, I don't know if you noticed it, maybe I just noticed it because I teach this, but we really ease you in on the first day or two, right? Like chapter 8, or whatever chapter it is, it's like the first couple of days we're easing you in. So you guys feeling okay? Alright. I don't know if there's anyone out there that has been interested in the difference between SL and HL, if you guys have heard about that, but HL doesn't do the beginning part. They're just bam, we're going. So that's one of the big differences. We don't ease in if you teach HL. Okay, so this one says, again, it's convert radians to degrees. Notice it says to 2 decimal places. So that does not mean 3 sig figs. So you want to make sure that you pay attention to the way the question is being worded. But we can start this one the same way. 3.179, still timesing it by 180 over pi. And I would just use your calculator on that one. We don't have to leave pi in our answer. This is not going to simplify out cute. So we can just use our calculator to get that answer. So make sure you know how your calculator works. So I've got 182.143281. So what would be to 2 decimal places? What would my answer be then? Absolutely. This is 3, so it's less than 5, so we don't have to round that up. And so our answer would just be 182.14. Mine's wrong right now, though. Absolutely. Make sure you do put that degree symbol on there. So there is my answer, about 182.14 degrees. And remember, you guys remember how pi is about equal to 180? Well, pi is 3.14, so it kind of makes sense. It's 3.147, if that's a little bit more, because that's a little bit more than 3.14. Okay. So our stat box, just one important idea from today. For me personally, the thing I would want to see when I turned back to this page would be that conversion. I know you wrote it in your notes once, but you know, research says that when you write stuff down, it helps you remember it. So whatever it makes sense to you to write in your stat box, I would go ahead and do that. And I'm pretty sure I fit 7, 8, and 9 on your calendar, so you shouldn't need a new calendar. You should be able to write in this assignment for 8A.